gentlemen and ladies and human beings of all kinds of wonderful friends of mine. Today, I hope to clarify, clear up, or help with the stats. We do have a quiz tomorrow. You have to trust me. If you hang with me on this information that we're going over today, and you take notes on it, and you kind of maybe glance at it for like 15 more minutes outside of class, I think you're going to do quite well on this quiz, on this stats unit. My goal is this quiz should, if you've been here, raise everyone's grade in this class. This one, that'll be tomorrow. Okay, so not everything on this packet we're gonna go over, and we're gonna actually add a little bit to it. So you guys have the patience for me? Okay, so let's take a look at that first page. You will definitely see this type of problem on the quiz mark. Did I not get you one? Not enough? Or did not get past that? Sorry. Whoa. Okay, a collection jar has a bunch of coins in it. So does everyone understand that we have this jar? Anytime we have a jar, we can't actually physically see into it in statistics. Here, I'll take that. I thought I grabbed one. I can't count. I'm learning well these days. All right. So in this jar, here you go. In this jar, there happens to be 50 pennies. There has to be 25 nickels, 25 dimes, and 100 quarters. Huh?
It's like $10. No, it's not.
Is it 25 out of 100? I mean 200?
So yeah. The first thing is, what's the number of coins that I have? 200. Okay. So that 200 might be a denominator for quite a bit. Okay. Oh boy. All right. So does everyone understand the situation? How we got 200 coins and feel good? Yeah.
Can't you also say that the 100 quarters is 50%, 50 pennies is 25%, and 25 nickels, 25 cents, you can say 1/8, so how much percent that is?
Oh, absolutely. Absolutely. All right. So we're good, and I like what you were going with. You're thinking at a different level, and that's awesome. So everyone understands we cannot see into this jar. So if we go in and we pick one coin, what's the probability I get a nickel?
25 out of 200.
Yeah, so I get 25 out of 200. Of course, you can change it to a decimal. You can reduce it if you want, or even just like that. Okay, there's no reason to get fancy. I'm not checking to see if you can reduce fractions and make them decimals. Okay, letter B. What is the probability? Pick one coin that I don't get a quarter. How many quarters are there? 100. So not quarter. So how many coins are in there that aren't a quarter? 100. So I have 100 out of 200, which is 1 out of 2. Or you just leave it like that. Okay. You know what that actually shows is that you have an understanding that there is that many in there, and if you keep the denominators and the fractions as whole fractions in this type of stuff at this level, it's totally fine. Okay. If I pick one coin, what is the probability I get a nickel or a penny? How many nickels or pennies are in there? So probability of nickel or penny. How many nickels or pennies are in there?
75.
Nickel and penny is 75 out of the 200 coins. Any questions so far? Okay, so that was just the one coin scenario.
Mister,
Yes, sir.
wouldn't it be 25? Never mind.
You good? Because it was a nickel or a penny, so that there was 50 pennies and 25 nickels, so that's 75 total points. Yeah.
Oh, so is it or? I mean,
You just add it together. So it's like, did you get this or that? Okay. Everyone okay so far? All right, so let's keep going. Let's expand the board a little bit. Down. All right. Letter D. I decide to pull 2 coins out. So I'm just going to label this as 2 coins. So the big thing that we have to comprehend if we pull 2 coins is I can pull one, look at it, put it back in. That means it's replaced. Or I can just pull one and pull another, and I don't replace. If I don't replace, the denominator has to change because the number of coins changes. Okay? So I decide to pull out 2 coins with replacement. So I pull out 1 coin, look at it, and I put it back in. I pull out another coin. Could it be that same coin that I pulled out originally? Sure. Okay, so I pull out 2 coins with replacement. So we're going to have a big R for replacement. What is the probability they are both pennies? Well, how many pennies did I have? 50. So I have 50 out of 200. That's my first pick. I put the penny back in, right? I put it back in. So is there still 50 pennies in the jar? Is there still 200 coins in the jar? Yeah, because I replaced it. So now we're going to multiply. And these you might want to reduce before you start doing it because 50 times 50 is a bigger number, 200 times 200. So realize that you can reduce that. That reduces to 1 over 4. Do you agree? And this also reduces to 1 over 4. And that's a lot nicer problem to work because you're multiplying 1 times 1 and 4 times 4. But you have a 1 in 16 probability that if you were to pull 2 coins out, you take one, look at it, put it back in, pick another one, you have a 1 in 16 probability you pick a penny and a penny. Good? Letter E. I decide to pull out 2 coins with replacement. So I have 200 coins each time. Agreed? So letter E. So I'll pull out 2 coins. And I have a replacement again. This is letter E. What is the probability they are both not dimes? How many dimes are in there? 25. So how many of them are not dimes? 175. So not dime and not dime. Okay? So we realize that there are how many coins that are dimes? I'm sorry? 25. So that means that there's 175 out of 200 coins that aren't dimes. Am I right? That makes sense? And then I'm going to also do this. I'm going to do it again. We're doing replacement, so it's this. Now again, that's a nasty number. Okay, you don't want to go 175 times 175 and 200 times 200. So you might want to reduce these fractions. I'd say 25 goes into both of them nicely. 25 goes into the top 7 times. 25 goes in the bottom 8 times. Is that okay? Same thing with the other one. So 7 times 7 is 49. 8 times 8 is 64. I can't write. 49 out of 64. That's the probability I don't pull a dime and a probability I don't pull a dime again. Again, you might want to reduce those because you'd be dealing with big numbers. Are you wrong if you're dealing with big numbers? No, it's just nicer sometimes. Some people
not reduce that?
Huh?
Will you not change that, or will you decimal?
Let's see, 1 and 7, and 49 go into 49, and the only thing that goes into 64 is 1, so that won't reduce. All right. That cool? Letter F. All right, so is everyone good? Up through F, or up through E. Okay, yeah.
What's D?
D was ABC.
1 out of 6.
1 out of 16. So you have 2 coins that were both pennies. So you had 50 out of 200, 50 out of 200, which is 1/4 and 1/4, which is 1 out of 16. And this one was not a dime, so we went there. Yeah. Let's see. I didn't start laying down. Let's see. That was A, B, and C. And again, you could reduce those if you wanted to. So we are coming down to letter F. So I'm pausing. This is a difference. We are changing the number of coins in our jar because we're not putting what we picked originally back in. Okay? So if we're picking 2 coins, the first pick I have 200 coins. If I don't put it back in, the second pick I have 199 coins. Make sense? We ready? So this is F. Okay. I decide to pull 2 coins without replacement. So I just need to know I have 200 here and I have 199 here. Okay? I don't care what the coins are at this point. It's just I know that I'm not putting the first one back in, so my denominator had to change. What is the probability they are both pennies? How many pennies did I have? 50. Okay? So if I had 50, there's 50 different coins I can pull out that are all pennies out of 200. If I happen to pull another penny out, how many pennies are left then? 49. And this is where, if you have a calculator, it'd be awesome. Don't just sit there and stare and go, I think it's like 178. Okay, go ahead.
49 over 796.
Oh, okay, because this reduced, right? That's 1 over 4. So you got 49 over what?
796.
796. I'll go with that. So we saw the reduce that took place here. 50 out of 200 reduces 1 over 4. Yeah.
How do we get the 49?
Okay, so you have 50 pennies, right? What's the probability to pull a penny and a penny? So let's say I did pull a penny on the first draw. There was a 50 out of 200 or 1 in 4 chance. So I put that penny over here. Give it Brandon. Brandon's not holding it. Now I have 199 in there. So that if that was a penny, that means there's 49 pennies still left in here. Does that make sense? Letter G. Can I move to G? Letter G. All right. I decide to pull 2 coins without replacement. What is the probability they're both quarters? How many quarters do I have in there? Holy cow. 100 quarters. So again, it's without replacement, right? So I have 200 here. I have 199 here. I have 100 quarters here. And I have 99 quarters here. Agree? Yes. So the reduce that might be nice is 100 over 200 is 1 over 2. Do you agree? And then that's 99 over 199. I don't know if that's going to reduce. So that's going to be 99, and then 2 times 199. Well, 2 times 200 is 400. So this is going to be 2, or what is it? 398. Thank you. So 99 out of 398 is my probability of pulling a quarter, giving that quarter to my friend, reaching in and grabbing another quarter. Okay? Are we okay up through letter G? Now we are going from pulling 2 coins. I'm trying to pull 4 coins now. I'm trying to pull 4 coins without replacement. Yes? This is letter H. So, I have a pick, I have a pick, I have a pick, I have a pick. I'm not replacing, so this one has 200, this one has 199, this one has 198, and this one has 197. Does everybody feel comfortable with how I just did that? Am I worried about right now what the top number is? No, I just realized that I'm not putting these coins back in. I'm pulling a coin, giving it to a friend, pulling a coin, giving it to a friend, pulling a coin, giving it to a friend. I'm changing the number of things that are in there. Now, what is the probability to get 4 dimes? So we have 25 dimes, yes? So we're saying, hey, yep, we picked dime. Cool. If I picked 1 dime and I gave it to a friend, how many dimes do I have left for my next pick? 24. If I picked out 2 dimes so far, gave them both to friends, how many do I have left so far? 23. If I picked out 3 dimes so far and I gave it to my friend, how many do I have left? 22. Now, these are multiplying fractions together, okay? Things that I might look at on here, I would probably recognize that this is going to reduce to 1 over 4. Can I stop there for a moment? Oh, no, wait, hey, time out. Shh, look over there. 1 over 8. Is that all right? Yeah. All right. Now, if I'm multiplying fractions together, this might have been a skill you might have forgotten about. Let's see. 2 goes into 24 12 times. 2 goes into 198. How many times?
2 goes to 198.
Yeah.
Where'd you get 2 from?
Because they're even numbers.
99.
99. Okay. Are we good there so far? Okay. Does that seem okay so far? So let me just rewrite what we have so far. And I'm just showing you how to reduce this. There's more reducing that can take place. But I'm multiplying fractions together. Okay? So there is, I would say 11 goes in here and 11 goes in here. What do you think? Let me just rewrite now with the reduce. There's more. I haven't even started multiplying. I'm just reducing these. But I want you to see that you can do these, because a lot of times with statistics, if you don't reduce it, you get an overload on your calculator because your calculator can't multiply numbers that large together. Okay? Let's see. I can do this one. 2 goes into itself once, 2 goes into 8 4 times. Let's do one more. 4 goes into itself once, 4 goes into 12 3 times. And let me rewrite what we have. So this is, oh, this is nice. That just became 1. I got 3 over 199 times 23 over 9 times 1 over 197. And I'm just reducing a fraction. Yeah. What do you got?
3 and 9.
Oh, yeah, you got one more. Cool. Let's see. 3 goes in that once. 3 goes in that 3 times. 23 is a prime number. So unless 23 goes into 199 or 23 goes into 197, I don't know. Will someone double check? Someone go 197 divided by 23.
197 divided by 23 is 5, probably.
5?
Probably.
I don't know. How much? 8.56. That means that 23 is not going to reduce. So my numerator is 1 times 1 times 23 times 1. That's 23. My denominator is 199 times 3 times 197. 199 times 3 times 197.
117,609.
600 and what? 9? Holy cow. So, what is the probability that I pull 4 dimes out of this hat? It comes out to 23 out of 117,609. Now, we reduce those fractions. I want you to take a look at, is there any part of this that you need extra help on? Does everyone comprehend how I reduce the fraction? The reason you want to reduce a fraction is it's very possible on your calculator if you go 200 times 198 times 197, or 200, 199, 198, 197, it's going to put it in scientific notation. All of a sudden you're like, Mister, what's this E thing? Yeah.
So for 8 you divide by 2 and you get 4 and then so you put you saw how many 4 points 12 3.
Uh-huh. Then 3 went into 9. So the nice thing, if you're reducing fractions, if you're multiplying fractions together, you can reduce anywhere on top to anywhere on bottom. You cannot reduce top to top. You cannot reduce bottom to bottom. But if you're multiplying fractions together, in this case you have a string of 4 of them, you can start reducing it. So 23 out of 117,609. That's a pretty low chance that this is going to happen. So, on our quiz tomorrow, you will see some of that type of problem. Is there any part of that problem that you need me to go back over, re-clarify for you? We good? Going once? Twice? So, it's recorded if you need to go back over it, okay? And I will... Excuse me. I will have these notes posted on Schoology as well. So if you want to watch the video or go to the notes or both, doesn't matter. May I move on? Yeah.
Can you just divide it each fraction by its own?
Oh, and get a decimal? Yep. Also works. Okay. I am skipping problem number 1, problem number 2, problem number 3, and problem number 4.
Which one are you going with?
Well, because they're not on quiz, so is that okay? Yeah. So I just got to do one of those and actually do it, make the whistle and do it. Okay. I am now on problem number 5. So locate number 5. So I have laptop, no laptop, total. Total, if I could spell. I have yes, I have no, and I have total. How do you whistle? 3. You're not learning how to whistle. This is my favorite whistle, Ray. How cool is that one? Oh yeah. That's what happens when your parents leave you alone in the backseat of a car on a road trip. Start making up noises. Okay. Here we are, number 5. Y'all ready for this? Okay. Front letter says all airline passengers must pass through security screens, but some are subjected to additional searches as well. Some travelers carry laptops, wonder if that makes them more likely to be searched. Data for 420 passengers aboard a cross-country flight are summarized in the table shown. Okay? So they have a laptop, yes, laptop, no. Or says no laptop, or so this is no laptop, and this is if they were searched. Yes or no? Okay? The probability that somebody has a laptop. How many laptops are on this trip? 72.
Oh,
Right? There's 72 out of the 420 passengers. Okay, could you reduce it? Maybe. I'd say leave it as that for right now. The probability that someone was searched. How many people were searched? Yes, good. Out of the 420 people. Cool? Is that all okay? Everybody set on how we gained both of those pieces of information. What is the probability that someone has a laptop or is stopped?
30.
A laptop. Wait. Probability they have a laptop. So laptop is this. What is the probability they have a laptop? Right?
Oh, 30 would be 72.
And then-
75.
And then
No.
or is stopped is this. Okay? So now, quick question. Think about this for a minute. Okay? So this is how we got the laptop information. This is how we got if they were stopped information. Is there a portion of that that I have to not count twice?
Yeah.
Which one? Careful. The 30. So I need to subtract the 30. Okay, so let's walk through that one more time. This is the probability that the person has a laptop, or that's how many people had a laptop going through in this search. Still with me? There was 175 people who had been stopped. We need to be concerned about this. If I don't subtract 30 one time, in order to get this 30, in order to get to the 72, you're counting these 30 people. In order to get to this 175, you're also counting these 30 people. So you have to take account. Let me take away one set of 30 so I don't count them twice. Because I'm counting this way. I count to get this total. I count to get this total. That total includes 30 two times, so I have to subtract that 30 from it. Okay? So 72 plus 175 minus 30 over the 420. Okay? You have a calculator, I think.
217.
217 out of 420. So again, you don't want that person to get counted twice. Okay? Are we okay up through letter C? Sound good? Okay. let's move to letter D. Letter D. The probability that someone is stopped given they have a laptop. Okay? So they're stopped given they have a laptop. Now, this is how you have to think about this. Let's say we have the 420 people in this room. Still with me? And I say, okay, any of you with a laptop, go over here. Everyone else stay over here. Okay? That make sense? So the people over here don't have a laptop. All these people that came over here have a laptop. Okay? And I'm going to say, all right, so how many people did I ship over with a laptop? How many people had a laptop in this study? 72. Good. There were 72 people that are on this side of the room. They all have a laptop. The rest of the people are over here. And I walk over and I pick somebody at random who obviously they have a laptop and say, hey, were you stopped? How many people were stopped? 30. So I have a 30 out of 72 probability that I separated my people, saying, all right, I know y'all got laptops. I got you. How many of you were stopped? Or go up to somebody and say, hey, were you stopped? And you have a 30 out of 72 chance of finding that person who was stopped who also had a laptop. So you separated the group into different things. Okay? And then letter E. Letter E. What is the probability that someone is stopped given, I think that's supposed to say, given they don't have a laptop, but we didn't. Okay? What is the probability that somebody was stopped and they have no laptop? Okay, given they have no laptop. So, our room is still separated. Remember these people over here? They all had laptops. I'm going to come over to the people over here who don't have laptops, right? Okay, so how many people in our study don't have a laptop? 348, right? Does that make sense? So 348 didn't have a laptop. How many, if I walk over to that group, how many that did not have a laptop were stopped? 145. So they didn't have a laptop, but they were stopped. 145. So I have 145 out of 348. Okay. All the people over here, 348. I walk over and I say, okay, you, come here. The chance that I pick somebody who was stopped, and I know they already don't have a laptop because I already separated them, but there's 145 out of 348. Are there any questions about problem number 5? Am I doing okay? I'm going to skip over number
Could we do 6?
How'd you do?
E. Okay, so we know that these people over here, they don't have a laptop. So I'm going to walk over to that group and figure out the probability that group that doesn't have a laptop was also stopped. So I looked on my grid right here. I have this many people that did not have a laptop, okay? And then I'm going to say, okay, I'm going to go 145 out of the 348. So I'm using that. I'm isolating my groups.
Okay, I get it now.
We okay? All right, let's see. I am skipping to number 9. Why is that? Because those others they might be they're on the test, but as more of a number 9. Okay, so we started with these yesterday, and this got a little goofy. It's kind of because I suck as a teacher, but
Will there be 3 diagrams on the quiz mark?
that's why I skipped it.
We can do number 6.
Nope, let's go to 9. Is that cool? The questions below refer to a box and whisker plots that compare homework time per night with TV/video game time per night for the same group of sophomores. Okay. So I would say this is probably in minutes because you probably didn't spend 60 hours on homework in a night. Okay? All right, so let's see if we can figure this out. Letter A. What percent of the sophomores? So remember, the one thing, I'm going to write this in place just so we have our eyes on this. Okay? 25% of my data is here, 25% of this data is here, 25% of the data is here, and 25% of the data is there as far as that goes. 25% of my data is here, 25% of my data is here, 25% of my data is here, and 25% of my data is here. So I'll make those all percents. Okay? Those percents have nothing to do with the number of hours spent. It's just that's how our data fell. So 25% of my data falls into each one of those categories. So within the box on either of them, 50% of my population falls. That's between Q1 and Q3. Okay? All right. What percent of sophomores watch TV/video games for at least 15 minutes per night? So that we're looking at this one, and we're looking at this category. 25%. Done. Okay? So if you realize how the box and whiskers is broken up into 25% categories, you're going to do just fine with this. Okay? Letter B. What is the third quartile for homework time? So homework time, third quartile is right here. So it's got to be 60. So that's going to be Q3. Is that okay? Okay? I got the hiccups right now. Excuse me. Is it more common for a sophomore at this high school to spend more than an hour on homework or more than an hour on video games? Okay? So, here's our hour mark right here. Here's our hour mark right here. This means I have 75% spend less than an hour on homework. Okay? What does this mean? What? TV video games, right? Okay, so let's read this again. Is it more common for a sophomore at this high school to spend more time, 1 hour, more than an hour on homework or more? So only 25% of our students spend more than an hour doing homework. I have 50% of my students that spend more than an hour watching TV. So do more kids watch TV than, or do more kids watch more than an hour of TV versus on homework at the school? 50% of our kids in this survey watch more than an hour of TV a day, where only 25% of our kids spend more than an hour on homework. Okay? Which data set has at least one outlier? Okay, so let's figure out the outlier. So on each data set, I'm going to go Q3 minus Q1 times 1.5. That's my equation so far. So Q3 is, for the homework, is going to be 60 minus 20 times 1.5. So that's 40 times 1.5. What is 40 times 1.5? What is 60 minus 40? So that's 40. 40 times 1.5. Is it 60? Okay. So we're going to look at that. That's for the homework. This is for the TV/video games. So I'm going to go Q3, which is 110, minus 15 times 1.5. So 110 minus 15 is 95. What is 95 times 1.5? You guys have the calculators. 95 times 1.5. How much? 142.5? Nope, what we're doing, okay, so now we're trying to determine if we have an outlier. Okay? If I add 60 to this, I get to 120. That means this is an outlier. Okay, because 120 is here. So that 190 is an outlier. Okay? Let's look back at this. So if I add 142.5 to this, if I add 142.5 to this, I get 252.5. Is 252.5 to the right of 225? Yeah, so there's not an outlier on the TV video game, but I have an outlier on the other one. So I take my Q3 minus Q1, 60 minus 20, multiply by 1.5. Whatever my answer is, I add to my 60. So I had 60 plus 60. Or wait. Is that what I did? Yep. So I had, what was it, my 1.5, 60? Plus my 60 is 120. So 120 happens right here. Being that 190 is outside of that, that means 190 is an outlier in our data. Okay, we doing all right? All right, flip over to the back side. It's blank. You with me? Flip over to the back side. It's blank. I'm going to make up a Venn diagram. Okay. Let's say at a particular school, 30% of the student body is in some sort of music class. Is that okay? So at some particular school, 30% of our students take some sort of music class. Let's say at that same school, let's say 20% of the students play either boys or girls basketball. Is everyone still with me? Now, at this particular school, when we asked our students, 5% of our students happen to play or do both. They did some sort of music class, and they played basketball. Does everyone understand our region? Again, we're making this problem up. We don't have this. This is on the back side, which is blank. We okay? All right, so if I create a Venn diagram, I'm just going to make a box. I'm going to make a green circle for our music. I'll make a blue circle for our basketball. And the red region is this region that's shared between them. Is that okay? Does everyone get how I've drawn my Venn diagram? Okay, so 5% of my students fall here. Is that okay? Now, remember those problems that we can't count twice? This is one. We can't count twice. So, if there is 30% of our students that are into music, but 5% of those kids also do the basketball, what percent falls here exclusively to music? 25%. Good. Okay? Of our basketball, which is 20% of our students, of the 5% to do that, so I'm going to put a 15% right here. Okay, so let me just pause and make sure you feel comfortable with how we just did that. Yeah.
So you just subtracted the 5 from each.
Yep, so the both stays here, but you have to realize 5% plus 25% is my 30%. 5% plus 15% is my 20. Is that okay?
Yeah.
All right. So problems, and so other things that we might want to realize is percent don't do. Don't do music or basketball. So if I add this up, I get 25 plus 5, that's 30. 30 plus 15 is 45. So what percent don't do either of those? 55. So there's 55% of my population that aren't involved in music and basketball. Is that okay? Where did the 30 go? Because 30% did music, and of that 30%, there was 5% that did both. So I have to have the 5 plus the 25 gives me the 30. And the same thing with the basketball. 20% did basketball, but 5% did both. So I have to make sure I don't count those people twice. Okay? So what would be the probability that they do music or basketball? It's not both. It's music or basketball. So what percent does music exclusively? 25. Hang on, get ready to do, Jasper. And what percent does basketball exclusively? 15. So if I add 25 and 15 together, I get 40% of my population. Okay? They do one or the other. Yes, sir.
I was gonna try and answer.
Oh, dude, was that what you're going to get? Do what?
Look, can I see the word?
Where'd you get 55? Where are you getting 55? That don't?
Yeah.
So I added 25, 5, and 15 together. So 25 and 5 is 30. 30 and 15 is 45. So 100% minus 45% is 55%. So 55% of our population, they are not involved in either. Okay, it doesn't mean they don't do anything. It's just those two particular activities they're not involved in. Okay, so guys and girls, if you reviewed the problems in that packet that we went over, you should do fairly fine on this quiz tomorrow. Meaning your grade should improve. Got it? The video will be up. The notes will be posted online on Schoology as well. So utilize it how you need to.